Hey there, welcome to ShareTreck. This is Raj here. Friends, today I'm going to talk to you about a new technique that I read about. It's called as Bridge RNA. It's a relatively new finding. And my first question was, how does this impact existing CRISPR-Cas9 technology and maybe base editing and other technologies? So I want to bring this to you. I hope that you would watch this from the beginning till the end, because this technology, I believe, might find a lot of applications going forward, because gene therapy as such is pretty expensive, and it has got a permanent nature once it is done. So I think alternate technologies which can deliver similar relief might be the next level of evolution for existing medicine. So we are going to look at something that's going to be superior to existing medicine, but not quite CRISPR-Cas9. That's where I slot this. So let me express all my thoughts. Let's get started. Welcome back, friends. A groundbreaking gene editing technique developed from bacterial jumping genes has shown promise in overcoming some limitations of the widely used CRISPR technology. This new method, spearheaded by scientists at the Arc Institute in Palo Alto, California, and the University of Tokyo, is detailed in two papers that were published in Nature on June 2026. The cornerstone of this technique is a molecule called Bridge RNA. If you were to then say, how does this compare with CRISPR-Cas9, then probably one of the main distinctions would be, unlike CRISPR, which creates double-stranded breaks that require the cell's DNA repair mechanism, Bridge RNA edits DNA without breaking both the strands, potentially reducing toxicity. The ability to program both target and donor DNA sequences allows for highly specific edits, and Bridge RNA can add, remove, recombine, and invert DNA sequences more efficiently than CRISPR, because CRISPR requires additional components for complex edits. And in terms of potential application, Patrick Su, senior author of the study, highlighted several potential applications. The first one is in cell and gene therapy for inserting chimeric antigen receptors or missing genes. And the other application would be addressing diseases caused by repeat expansions of genetic translocations by excising and inverting problematic DNA segments. And while CRISPR has been transformative with recent FDA approvals for treating sickle cell disease and beta thalassemia, its limitations include potential toxicity from double-stranded breaks and challenges in inserting large DNA sequences. Companies like Tessera Therapeutics and Prime Medicine are developing alternatives to address these shortcomings. I can talk about base and prime editing as a couple of examples. The Bridge RNA technique still is in early stages and has shown success in bacteria. And in the next step, we'll have to test it in the human cells. Testing the technique's efficacy and safety in the human cells is going to be important before any further advances can be made. Enhancing precision and efficiency is a major factor that will drive this quest. So coming back to my original thought, when I read this article, my question was, what happens to CRISPR-Cas9? Well, here is what I understand will be the differences. Let me elaborate. Now, I have a diagram out here which can give you comparative analysis. You can refer to this chart while I speak on the background. Bridge RNA has got effectiveness for temporary modulation of gene expressions. Its effects are reversible and can be fine-tuned over time. However, it does not provide a permanent solution to genetic effects. CRISPR-Cas9 offers a potentially permanent cure by directly correcting genetic mutations. This makes it highly effective for treating monogenic disorders, but comes with risks of off-target effects and unintended genetic changes. Next, if we were to look at safety aspect, Bridge RNA is generally considered safer in terms of off-target effects because it does not alter the DNA. However, repeated administration may pose challenges, whereas CRISPR-Cas9 carries risks associated with permanent changes to genome, including off-target effects and potential immune responses. And if you were to look at it from a point of view of therapeutic strategy, Bridge RNA is suitable for diseases requiring temporary intervention, conditions where permanent alteration is not desirable, or as a complement to permanent therapies. Whereas CRISPR-Cas9 is ideal for diseases where permanent correction of a genetic defect can cure the disease or significantly ameliorate its symptoms. And I think overall, in conclusion, I would say that Bridge RNA and CRISPR-Cas9 can become complementary. They serve different but complementary roles in gene therapy. Bridge RNA offers temporary modulation of gene expression, making it useful for situations where reversibility and fine-tuning are important. In contrast, CRISPR-Cas9 provides a more permanent solution by correcting genetic defects at the DNA level, offering the potential for a once-and-done cure for certain genetic disorders. So now here is what is going to happen next. Now, if you have to look at the life of PhD students, a PhD in biotechnology, basically either they become lecturers or they have to wait for somebody to drop dead so that they can occupy that seat and grow to the next level. But with inventions or discoveries like this, what would happen is that they could get along with their guide and launch a new startup, and the startup can get Series A, B, C funding, and then it can come up with an IPO, and lo and behold, all these PhDs will be CEOs and they'll be making big bucks. So it's a new era, and I'm not being sarcastic about this, but I'm saying that finally, after a long time, the PhD students are getting something which is long overdue. And I hope all of this kind of generates enthusiasm for more research to come up with out-of-the-box thinking, so that we can have a wide range of set of tools that can be used to work on our genetics in order to give temporary or permanent relief from various genetic disorders. So that's what I am hoping for, and hats off to this team for coming up with this new application. And with this, my friends, I would like to bring this video to an end, and I'll catch up with you again in the next video. Bye for now.